Hi, welcome to the next instalment of my solar accumulator build. The battery pack, which is here, is done, tested and working. The cells are all reasonably balanced according to the Hobby King meter. I'm now trying out the charge unit, and what I'm using is these 3 amp charge. They're supposed to be MPPT, but they're kind of pseudo MPPT. They kind of hold the panel voltage at about 18 volts to achieve as close to the maximum power point as is possible. They actually are surprisingly efficient. They don't seem to lose any actual wattage. Use about a watt in their conversion, having tested both of these. I've got 2 of them here. What I've done is I've mounted them to a heatsink. It's like a 100 by 60 heatsink, 100mm by 60mm. I'm running the outputs through a blocking diode. Here it's a 16 amp blocking diode. I did that mainly because the outputs of these are a little high for my liking. They're kind of 12.8 volts rather than 12.6, so they're overcharging the cells a little bit hard. So putting a blocking diode in will drop their output by the voltage of the diode. It now drops them down to about 12.5 volts, which actually I think is quite acceptable. It basically means that the cells won't get overcharged. I've got these linked in parallel, so I've got the outputs, sorry about that, got the outputs linked both on the positive and the negative. The positive goes up into the battery on the positive side, the negative goes all the way around here, excuse the mess on the bench, up to the BMS input at that point there. I'm also experimenting with linking the inputs in parallel as well. So not only are the outputs in parallel, the inputs are in parallel. You'll notice that both the red lights, they're a bit difficult to see, red light there and the red light there are both on, showing that they're charging. The voltage on the Hobby King is creeping up slowly. I don't know what current I'm pushing, I've not measured it, but my bench power supply is outputting nearly 20 volts, 19.9 volts at 4 amps. So converting that down to 11.4 volts, you're going to be pushing closer to sort of like 5 amps, I would think, into the cells at the minute. So these boards obviously can be linked in parallel on both the input and the output. They don't seem to have complained, nothing's gone up in smoke. They are warm, but actually it's the inductor that's warm and the MOSFET, which is the 2 components I would expect to be warm, and the output diodes as well. They're also pretty hot. So the 3 components here are really warm, and the resistor. Those 5 components there are warm, but obviously being on heatsink, they will be taking the heat to the heatsink, which actually is warming up quite effectively. I may have to put a fan on that, maybe a temperature controlled fan, bearing in mind that this is going to be inside a case. But the testing will continue. But I preferred the idea of linking these in parallel because it means that I can be more flexible on panel input. The original idea was to have 2 sets of solar inputs with a maximum capacity of 50 watts each. But if I link all of the inputs in parallel, then I can actually have 1 100 watt panel into one of the connectors, and then hopefully the power will share equally between these 2 boards, so that it'll charge at the same rate. It just gives it a little bit more flexibility. So that's where I am at the minute. I'm just basically testing. This is getting quite warm now, this heatsink. It's probably up to around 30 degrees, but of course it's just choked off. If there's a fan on the back to move air from that, it would be much cooler. So there we are. I'll continue with the build and show points of interest as I go along. But for the time being, I'm just going to experiment with this to make sure that these charge these cells reliably. But they're certainly, the voltage is creeping up. So even a few minutes of pushing power into them pulls the cells back up. So I had actually drained these down to 3.7 each bank, each group of cells. So their storage charge basically. But I did that so that I could test these units and see how they charge in parallel. So there we are so far. If you like this, then keep coming back and I'll update this as I go along. Thanks for watching.